So by this point, you should have a clear understanding of which actions you would at least like to test in the upcoming season in order to see if they will move you effectively towards the goals that you defined in your context. Now, the last step is to create an experiment that connects to all of the metrics that you've decided to measure. The fact that you've already selected the metrics you want to measure makes this process a lot simpler. So let's take a look now at the experiment design template PDF that's included in this step. This is a very simple form to fill out, and with time, you'll get very good at it. At the top here, you can put the name of your test, so that makes it easier for you to organize, and put if there is any deadline or duration of the experiment that you're going to be conducting. It's also important to know who is responsible to making sure that not only the actions of the experiment get carried out, but the measurements that you're going to do to make sure that you gather as much useful information from this process get carried out as well. So make sure to assign and put somebody responsible for this at the top. Now, the first step is creating a hypothesis. A hypothesis is the combination of the actions that you want to take and what you believe the effect will be. It's really important to state these in clear terms. After going through this sheet, I'll take you through a real example so we can look through it. In the next box, you're going to be articulating how you're going to demonstrate that. A description of the actions that you will take and how. And then how are you going to measure it? By this point, you should know exactly how to do that because you've chosen the metrics ahead of time. The metrics that you plan to use and how you plan to measure it are what goes in here. And lastly, how will you know if you're right? Describe these results that you expect to see after completing the experiment. Make sure that it's specific and that the way that you plan to measure it will get you that information. So let's take a look at an example that I wrote up. So here at the top, I wrote biodecompaction is the name of the test to give it reference, and the deadline is going to be September the 10th, 2024. I have assigned it to myself, and this gives me 9 months for completion. So the way that I wrote it out is always with this first portion of the statement already assumed. So we believe that by applying compost tea to the fields every 2 weeks, that we will see an improvement in the soil's compaction rate of 10% or more. So this is the action, this is the time, and this is what we expect to see as a result. That expectation is core to the hypothesis. So again, by applying compost tea onto the fields is the action. Every 2 weeks gives it a time frame, and that we will see an improvement in the soil's compaction rate of 10% or more is the hypothesis or the expectation. Your hypothesis statement needs to have each of those elements. In the second statement, to verify that, we will perform a compaction test at the beginning of the year and again on September 10th. That is the only thing that we have to put in this portion because it's just talking about how we are going to get the results. So again, performing a compaction test is the action at the beginning of the year and again at September 10th are what are needed to give us the results that we're looking for. In the metric, we start the statement by and measure. So what are we actually measuring through these actions? So in this case, it's the centimeter depth of a fence post inserted into the soil at 3 different locations on the field, and we will compare it to that measurement that is taken again on September 10th. So what you are measuring is the centimeter depth of a fence post inserted into the soil at 3 different soil sample sites so that you get a good overview. And this has to happen twice for you to be able to compare the results. So that's what is being measured. And then finally, of course, we know if we are right means to say that we know that we have met the criteria of our hypothesis here at the top. If we are right, if the measurements taken on September 10th show a 10% or more improvement compared to the original results. So we need to take the complete value of the centimeters that were inserted in the first test at the beginning of the year and the number of centimeters inserted on the second one, and then calculate that to see if there is a 10% change or more. In this case, it would need to be increased to show less compaction. And that will tell us whether we have proved our hypothesis or our assumption was incorrect. And of course, that's why we do these tests. So by now, by going through all of these different exercises, we've identified and challenged assumptions. We've assessed resources and support for strategy creation. We've taken an overview of the decision-making framework and all of the different questions that we can use to challenge our assumptions. And we've learned how to create a hypothesis and an experiment sheet that will guide the implementation of our strategy to make sure that we're getting all of the possible learnings that can inform our decision-making in the future. In the next video, we're going to take this strategy that we've built and move it into the planning and the preparation so that we can implement this out in the field.